association rules, we have understand that there is a large of transactions. Inside the transactions, we are going to identify the frequent patterns, which was most repeated one, the frequent patterns, right? So in the given database of transactions, we are going to identify the frequent patterns, which was most repeated, commonly repeated. So this is association rules generally used in the market basket analysis, right? And we have seen what is the use of association rules, and I have explained in the last class very clearly about the association rules and examples of that. And so here the question is, if a person buys a product A, what is the probability that he will buy the B? Means if a person buys with respect to a bread, what is the probability that he will buy the with respect to jam? And if the person buys with respect to bread, what is the probability that he will buy with butter? What is the probability that if a person buys mobile phone, what is the probability that he will buy a screen guard? All right. Or with respect to back case. So if one of them is getting a combination, I want with a combination, not with the individual wise, not with probability of A or not with individually probability of B. Individually of probability of A means total number of transactions, how many are there inside that this particular product A, in how many transactions it is available, we are going to write. So individually the probability of B means we are going to identify total number of transactions in which probability B is occurring. I don't want like this. I want the probability of both A and B, right? So here we are going to measure this measures of association. How we are going to measure the association means by using the support, confidence, and lift. Okay. So now let us take an example. So what is support? Support means frequency of both A comma B. Means this particular totally this A and B both available in the given total number of transactions, both of them. That is frequency of A and B divided by with respect to total number of transactions. Confidence means frequency of A by B divided by frequency of A only with respect to frequency of A. Similarly, support divided by support of A into support of B. Lift of A and B is equal to support of A and B divided by support of A into support of B. So let us take an example and we calculate everything. So now what is meant by support? Support means how frequently that set of items are occurring in the total number of transactions is called as support. Okay. Support is also nothing but probability, right? So support is it is a measure of how frequently a set of items occurring in the total number of transactions. That is, for example, support of A and B. You have taken the formula called as support of A and B. In that, what is the formula you have written? Support of A and B is equal to frequency of A and B divided by total number of transactions. Means nothing but, for example, A and B is milk and bread. So total list of transactions, in the entire list of transactions, how many transactions has A and B, both of them? Okay. For example, I'm having bills, multiple bills are there in the demand. Transaction 1, transaction 2, transaction 3, like this multiple transactions are there. Within these transactions, I'm going to check how many transactions are having both A and B. Okay. Not only with A, not only with B. I want with A and B. So I'm going to check the transactions of A and B divided by total number of transactions is called as support, right? So it is a measure of how frequency a set of items. You are not working on the single item, a set of items that occurs in the total number of transactions. For example, you are checking with respect to milk, bread, jam. Now this entire set is considered as with respect to 1, and this considered how many are having with respect to milk, bread, and jam in the total number of transactions. Means nothing but indirectly you are calculating the probability only. Nothing but you are calculating the probability only, right? But here it is called as support. Now next we are having the confidence. Confidence means it is the measure of how often the items of Y appear in the transactions that contain in the X. Okay. So that is given by the confidence. Now we are going to use here frequent item sets. We are going to generate the frequent item sets, and based on the frequent item sets, first we are going to create the frequent item sets, multiple frequent item sets. Okay. So here This association rule is worked on the algorithm called as a priori algorithm. Okay, the association rule name called as a priori algorithm. In the ML algorithms, it is called as a priori algorithm. Okay, now in the association rule, how we are going to do this mining is we are going to take the support on the minimum support threshold. Some value we are only going to give. Sir, how we are going to select this minimum threshold is the most important point in the association rule. This is the most important one. How we are going to select. How we are going to select this minimum support threshold and how we are going to select minimum confidence threshold. So these values, based on this only, the frequent items we are going to select. So let us take an example. Okay. So here, these are the transactions. Please take a note of these transactions. Write the note of transactions in your notes so that we can do the manual calculation one by one. The first transaction consists of milk, bread, rice, and book. They have purchased 4 items in the first transaction. In the second transaction, bread, jam, book, and pen. Transaction means nothing but bill. Okay. Done. You have taken the list of transactions. Now, what are the steps involved in this? Miss, the steps first determine the support of item sets in the transaction base and select the minimum support and confidence. You have to fix your level of support and confidence. You have to fix. How we are going to fix? Miss, first you'll fix some value of initially. I'm going to take this value. This is, I already told you, right? This is probability. So probability will always lies between 0 to 1 only. It can't be more than 1. If all the transactions contains your set also, n by n also, it is maximum is 1. Okay, for example, total 1000 transactions are there. In all the 1000 transactions, that particular item is repeated also, it is maximum value is 1. It can't cross more than 1. So I'm going to take a support of 0.5 and a confidence of 0.5. Assume initially I have considered this one and later I'm going to change. So here, first we have to take the frequent items, whatever the frequent items are there. So in this particular given list, in this list, first I have to make the like this, the encoding. This is called as encoding, one hot encoding or dummy encoding, or this in this particular association rule, this is called as transaction encoding. So see in your first one, first transaction ID consists of milk, bread, rice, and book. So remaining jam and eggs and pen are 0. So what are the unique items are there? Each unique item is considered in the column name. How many unique items are there? Each unique item, whatever the unique items are there. In the entire transaction history, whatever the unique items are there, it is considering like this. Out of which the first one is similar, milk, bread, rice, book. Remaining all are 0. Sir, here it is a small data set. You are going to make like this. For in the DMAT, we are having multiple items, right? So items will be with respect to, if you consider the brush, like toothbrush. In the brush only, we are having multiple items, multiple models are there. Now, how they are going to keep these many transactions? Miss, that is a large amount of data. There, they are going to process the large amount of data. Just we are processing the small amount of data. In the demand, they are processing the large amount of data. But the end of the thing is, finally, they have to do for this. If they want to identify the analysis of each and every transaction, is they have to do the same transaction encoder. So once they identify the transaction encoding, they have done the encoding. Once this encoding is done, only we can give to the machine. Without encoding, the machine will not understand. So that is the reason we have to do the encoding. Once we have done the encoding, so each transaction was considered. If that item is available, means 1. If that item is not available, means 0. Remaining part is automatically 0. Right? Whichever the item is available, that item I am considering as 1. Remaining other items I am considering as 0. Right? Now, here, first, I'm going to take the frequent items out of first two items. I'm taking the combination of two items, that is milk and bread, milk and jam, milk and rice, milk and eggs, milk and book, milk and pen. This comes under 2. Similarly, bread and jam, bread and rice, bread and eggs, bread and book, bread and pen, jam and rice, jam egg, jam book, jam with pen, rice with eggs, rice with book, rice with pens, egg with book, egg with pens, and book with pen. So I'm having with respect to each 2 combinations, what are the 2 combinations are there? Every 2 combinations I'm going to take. Every 2 combinations, not only this or not only that, every 2 combination. Whatever the 2 combinations are there, 2 items combinations is possible. Every combination I'm going to write. Similarly, 3 combinations. Whatever the 3 combinations possibilities are there, every possibility I will write. Whatever the 4 are there, 4 combinations also I will write. 5, 6. And finally 7. Total 7 items are there. 7 items into a one set. So like this, I'm going to make all the 2 items. Here, this is an example only. I have not given this. These are the one only. This is an example where we are going to consider 2 items, 3 items, 4 items, a combinations of everything. Now, how we can calculate this support and this confidence based on the support and confidence? For example, I have considered the support of 0.3. I'm using the word called as I have considered. Sir, how you are going to consider is the question. First, we'll take for 0.3. We'll go with the 0.4. We'll go with 0.5. Later, we'll go with 0.6, 0.7, like this. Sir, like first, for example, 0.3 we have selected. After that, 0.4, how we are going to change? That one is based on the total number of, for example, with this combination, multiple frequent items are there. So many item sets are available. Then what we are going to do? We can't give the combo offers for multiple things, right? We can give only 1 combo offer or 2 combo offers, or particularly I want with the milk, which is the most selling. Or assume that in my particular shop, bread is not getting sold. So for bread, what is the best combination? For that one only I will see. Within that, which is having the higher support, that I'm going to select, right? Assume if it is 0.3 and if it is 0.6. Okay, minimum support of 0.3, minimum confidence of 0.6 is there. Then how we have to calculate? First, let us see that one. So now rice X, both of them are there. Okay, this is A and this is B. Now what I'm going to do, support of A and B. First, I'm going to calculate the support of A and B. What is meant by support? Support means nothing but frequency of A and B divided by total number of transactions. Here, total number of transactions are 6 transactions are there. Out of 6 transactions, how many of them are having rice and X? Rice, X, no. Rice, X, no. Rice, egg, done. Rice, X, done. Rice, X, no. Rice, X, done. So 3 transactions are there. So 3 by 6, which is 0.5. This is first one, clear? So I'm considering this one as A and B. 2 frequency item set. First, I'm working on the 2 item sets. Later, 3 item sets. Later, 4 item sets. First, for 2 item sets, if A, then B, right? So here, I'm considering rice along with the X. So the support I have got is 0.5. Now I'm going to calculate the next one is called as confidence. Now, what is meant by confidence? Confidence is nothing but frequency of A and B divided by support of A. Only support of A. Support of A means only of A items. That is only rice. So with respect to the frequency of A and B, the numerator again remains same. That is this one, 3. It is not going to change. The numerator is not going to change. Down denominator, instead of considering all the items, I am going to consider only support of A. Support of M is only with respect to rise. 1, 2, 3, 4. 4 items, sorry, 4 transactions are there. So it is 3 by 4, which is 0.75. So I have calculated the support. I have calculated the confidence for this one, for this combo. Okay. Now, as per my rule, since 0.5 is satisfying the minimum support and 0.75 is satisfying my minimum support of 0.6, since these both of them are satisfying my condition, so this I am considering as the combination, as the association rule. If, for example, this one I have got a support of 0.2, and if it is not meeting my condition, if this is not meeting, both of them should meet. If one of them not meets also, I will not consider as the rule. Is that clear? Now, let us take one more example. Example number 2. Now here milk with bread and jam. Here 3 items set I am considering. So now milk, bread and jam. Now again you calculate the frequency of A, B, C. 3 of them should be available. Now what is the frequency of milk, bread and jam? Milk, bread, jam. No. Bread and jam. No milk is there. So milk, bread, jam. Yes. Milk, bread, jam. Oh, done. Bread jam is there. Oh, milk is not there. Okay, done. Only 2. So 2 by 6. 2 by 6 is 0.333. Right? Now, next confidence of support is 0.33. Now I am going to measure the confidence. Confidence is given, the numerator remains same. That is 2 divided by how many number of milks only is there. That is 1, 2, 3. So 2 by 3, which is 0.667. So once I have calculated this support and confidence for the given data, and this, it is satisfying the condition. So this I am going to consider as the rule. Okay. So whichever the combination satisfies my things, that I am going to consider as the rule. Whichever is not satisfying the condition, I am going to ignore that one. Right. Let us see the coding part. Now, right. So the same example, whatever I have shown you in the PPT, the same example I have considered here. Okay. The milk, bread, rice book, the same example as it is. The same 6 transactions I have considered. Okay. Now here I have considered this one in the list. Okay. Nested list. Now here from MLX10.preprocessing, I'm going to import the transaction encoder. So once I import the transaction encoder, I'm going to fit and transform on the data. Sir, what is the difference between transaction encoder versus one-hot encoding? In the one-hot encoding, we have to use the drop first. The one of the variable we have to drop. Here we are not going to drop none of the variable. Nothing we are going to drop. And that too, this is for the free, based on the transactions. So it is considered as the transaction encoder. Okay. Now, once this transaction encoder is done, now I'm going to create the pandas, and inside the pandas, I'm going to keep these values. Whatever the values I've got, that values I'm going to create the pandas. So if you see here in the pandas, I have got with respect to true, false, true, false. So like this. So wherever the true is there, that is equal to 1. Wherever the false is there, that is equal to 0. So in the first transaction, I'm having book, bread, jam, and milk. So rice. So, sorry, bread, book, yes, milk, and rice. So these are the 4 transactions which I'm having. So for these 4, I'm having the true. Remaining, it is representing as false, right? So now, for example, if you have considered this already as instead of lister, for example, you have considered as a data frame, is automatically it will consider as data frame. Since I have considered as a lister, this one will be converted. After converting this one, whatever the output I have got, if you see the output is TE_array. If you see the output, I have got the output like this. This output I am considering as a data frame. Okay, whatever the list array is there, 2-dimensional array, I am converting as a data frame. Right now, so from MLX10 frequent underscore patterns. Okay, import the a priori algorithm. And here you are considering the a priori algorithm of DF with a minimum support of 0.5. Minimum support of 0.5. Use the column names is equal to true. So these are the combinations which supports the minimum 0.5. Support of 0.5. This is the individually book, individually bread, individually eggs, individually everything are having the supports, and the combinations also 2 combinations and 3 combinations. How many are there? Every combination is going to try. Each and every combination it will try. And I'm going to get with respect to each and every combination which satisfies the minimum support of 0.5. I have given the support of 0.5. Now I'm going to take the association rules where the minimum threshold of confidence of 0.5. Okay. Now let us take a 0.5 of threshold. Now see how many are there? Total 17 are there. 17 are satisfying your requirement where minimum support of 0.5 and minimum confidence of 0.5. Now you don't want these many. You want only 4 or 5. Less number of transactions only you want. Means less number of items only you want to sell. Let us increase this one. So now instead of 17, we are going to get to 7. Okay. Now we have got with respect to 13 items only. Okay. 13 combinations only we have got. Now particularly in that particular shop, bread is not getting sold. Assume that bread is not getting sold. For bread, they want to give some kind of offer or something. They want to increase the sales in the bread. Now, first they are going to say for bread, which is the most combination, bread with jam. Okay, bread with eggs and bread with jam, bread with milk, bread with rice. Like this I'm having. Now, out of all of them, which is having the highest support? With respect to this egg with bread, 0.5, jam is having 0.66, bread with the jam it is having 0.667. Bread with milk is having 0.5. Bread with rice is having only 0.5. Now, out of all of them, which is having the highest support means this is having the highest support. These two. Out of these two, which is having the highest confidence? That is bread with jam. So, I'm going to create an offer with bread with jam. Okay, whoever are purchasing the bread. So, for example, if I want to clear my stock, clearance sale. For example, bread is going to expire in just 2 days. In next 2 days, it is getting expired. The bread packet worth is 25 rupees, out of which I will get a profit of 2 rupees. If I sell miss, I will get a profit of 2 rupees. So the selling, buying price itself, it is 23 rupees. Okay. And selling price, whatever the selling price is there, selling price is of 25 rupees and profit I'm going to make 2 rupees. Now for this 2 rupees, now if within 2 days, if I don't sell means, it is going to be a loss for me. Instead of rather than getting loss of 23 rupees, it is better to get a loss of 4 rupees. 4 rupees or 2 rupees, something loss is better than getting loss of 23 rupees entire thing. Now what I'm going to do for this bread packet, Kisan Jam of 2 rupees, Kisan Jam packets, 2 packets I'll give free. Okay. So now by giving that 2 Kisan Jam packets, now these 2 rupees Kisan Jam packets of 2 into 2, 4 rupees. Now this 4 rupees is actually loss for me. Okay, I'm giving for free of cost. This is actually loss for me. Now, if I sell this bread packet for 25 rupees, I'll get a profit of 2 and overall loss is 2 rupees only. Now, getting loss of 2 rupees is better or getting a loss of 23 rupees is better. If it is loss is fixed means getting less loss, the business people will try to get into the less loss if loss is fixed. If loss is not fixed, for example, we want to make the profits only, they will think about the, with respect to the profits, how they can make. So if the loss is already predetermined, means in the next 2 days, I'm not able to go sell this many bread packets. Now what they are going to do is this one. Right? In the DMart, the cool drinks will be there, right? 2.25 liters, whatever the cool drink bottles, buy one, get one free. So that they are going to create based on the rules. So if the cool drink to cool drink only is having the more confidence and more support is there, then automatically buy one, get one, they are going to keep. For example, bread with jam is there. Out of all the bread packets, why you have selected bread only? Why you have selected this one only? That is my requirement. In my particular shop, bread is not getting sold or bread I want to sell. I'm having more number of packets. For example, bread packets directly from the industry, manufacturing industry itself, wherever the bread was manufactured. From there itself, I have purchased more amount of quantity. Instead of purchasing 10 packets, I have purchased 1,000 quantity directly. 1,000 or 10,000 quantity bread packets I have purchased at a time. And I have distributed to the different stores. I am having multiple stores, that is DMart. DMart has purchased a total 10,000 bread packets from directly from there, and it has distributed these packets to the different stores within the Hyderabad. Overall, when they have purchased it with 10,000 packets, their buying price will be very less. Their profit will be very high. Out of that profit, still they can attract. For example, their buying price, a normal retailer shop, a normal general shop, they will get that bread packet for 23 rupees. Means these people, since they have brought 10,000 packets at a time, they may get at 17 rupees only. So now who has brought at 17 rupees? Now they'll give with respect to the offer price. Instead of selling at MRP of 25 rupees, they'll sell at 22 rupees. Okay, they'll write MRP. MRP is equal to 25. The DMart offer price is equal to 22. They will make like this. Now this one is they are reducing their profit. Okay. So why they are reducing their profit? Sir, who will not be interested in profits? Everyone will be interested in profits. But why they are still reducing their profits? In order to get the more number of customers. In order to attract more number of customers. That is the only reason. So for attracting more number of customers or to get the more number of customers, instead of selling for 25 rupees and selling only 10 packets, instead of that, for sell for 22 and sell for more number of people. They will get the more profit and the customer base also will be more. Okay. So due to this offers only, if the DMart has sold at everything in MRP, now DMart will be that much of famous. Huh? Why DMart is famous? Because in the DMart we'll get the very less prices. That DMart is not going to advertise also. The public only doing that advertisement also. That is mouth publicity. So the mouth publicity they have spread in such a way that DMart is going at the low cost. Who are very near to the DMart, everyone will go to the DMart only. They will not go to the any other supermarkets. Okay. So the reason behind that is that they are doing with respect to the business strategies. We are having different types of business strategies, out of which one of the strategies is association group. This is not the only strategy. This is one of them. They are having multiple things, right? For example, this is winter season. In the winter season, they want to bring with respect to the jackets, sweaters or jackets. They will keep in the DMart. In the whenever the summer season is there, they'll not keep that one, right? They'll not invest 1 rupee also on the jackets or with respect to that. Whatever they're having, they'll continue their sale only, but they will not invest. At that time, they'll invest on the with respect to ACs. Now, if you go to the DMart and if you see the AC is available or not, miss, they'll be having only one or two models only will be available. But if you go in the summer, that too in the peak summer, more number of models will be there. That too price will be very high. Now, what they are doing indirectly, everyone knows the summer starts in the month of March 15th. After that, slowly it will start. Okay. Done. Now they know that date of March 15th. Now what they are going to do in the March 1st to March 15th, they are going to do the investment on the ACs. They will completely do the investment on the ACs and they'll purchase that one. And once they purchase that one, they'll keep that investment for 1 month. They'll wait for 1 month. Once the AC prices has hiked, then they will open their things. This is one more strategy. Different persons will do in a different way. Right? Is that clear, guys? So here, where the minimum support of 0.5 I have given. Sir, instead of 0.5 support, let us increase to 0.6. There is no rule. No rule of 0.5. One, for example, your whatever the DMart manager has told, minimum 50-50, what is that? Let's check. For example, if I am asking 0.9 support, how many are there with 0.9 support, miss? Not even one item is there. Then what is the use of writing 0.9 here? Is there any use of writing 0.9? So just you are going to check. So here with 0.8, only the bread is there. Bread is only getting sold in that particular shop. Whatever the transactions are there, within these transactions, most common thing is bread. Bread was repeated 5 times, if you observe. Remaining all of them are most four times only repeated. This one was repeated 3 times. This was repeated 4 times. 3. Sorry, this is 5. This is 4. This is 4. And this is 4. And this is 3. And this is 3. This one was repeated 5 times. 5 divided by 6, which is 0.833. So that is the reason it is printing with respect to, it is giving the bread. 5 by 6. 5 transactions out of 6 overall. So bread is getting more sold. But I want with a combination. Along with this combination, with a threshold of 0.7, I'm not getting anything. With the support of 0.8, bread is there. With bread, which is most repeating, means nothing. With the threshold of this one. Threshold of 0.3. Okay. Nothing is there. So just we are going to adjust ourselves with respect to where we can get more number of things. So this we are going to change. Every time we are going to change. Okay, now I have got at least something. Now I'll see here, out of bread and jam, which is having the more probability, means the more combination is whoever are purchasing the jam, they are purchasing the bread. Whoever are purchasing the bread, the less probability that they'll purchase the jam. But who are purchasing jam, they are purchasing with bread. Means jam is generally in the bread only will use, right? The only option of jam is bread only. Obviously, the person is purchasing jam, means he has to purchase the bread only. So that is the reason it is having with the confidence of 1. Wherever the jam is there, bread is automatically there. 1 means the meaning is, this is A, this is B. If A was purchased, what is the probability of B? And B is purchased, what is the probability of A? Is that clear? So for example, here, sir, support is same, but how the confidence values changes, sir? Because jam and bread and jam both are same only, na? Why it is changing? For example, here, you are taking jam with the bread. Okay. Now, support of A and B. Support you are calculating. Support is nothing but frequency of A and B divided by support of A. Now, support of A is which one? Jam, right? So, frequency of A and B is, how many transactions are having with both A and B? That is bread and jam. 1, 2, 3, 4. 4 transactions out of 6, which is nothing but 0.667. 4 by 6. Okay. Now, next one is confidence. When you are measuring the confidence, frequency of A and B divided by support of, sorry, this is total number of transactions. This is total number of transactions, that is 4 by 6. This is support of A only. Just we have to write support of A only. That is nothing but 4 by jam you have to consider. A is now jam, exclusively jam. Jam is with respect to 4, which is 1. Now the same question with respect to bread with jam. Now support remains same. A combination will remain same. Support will not change because divided by total number of transactions. But if you comes under confidence, now the confidence is frequency of A and B divided by support of A, where the support of A is now bread, not with jam. Earlier the support is jam. In this example, whatever the example you have written, in this example, the support of A is with respect to support of jam you are checking. Here you are checking with respect to support of bread. Frequency of A and B divided by support of bread. Bread is your A. So that is the reason the confidence is changing. Whereas the original support, whatever the support is there, that is not changing because a combination, both the combination, whether bread and jam or jam and bread, both will be the same only. Support will not have any difference. But whereas confidence will have the difference because confidence is with respect to the value of which one you are considering initially. For that, what is you are considering the second one. What is the probability of purchasing the cool drink? First, you have to purchase the cool drink. For that, Lay's packet. And for Lay's packet, what is the probability that you are going to purchase the cool drink is different. Who are going for purchasing the Lay's packet, they will not purchase the cool drink, right? It is not mandatory. Very less number of people will purchase. Who are purchasing cool drink, there is a high probability that they will purchase in the Lay's packet. If you travel also, while traveling also, will purchase Lay's packet along with the cool drink. The person who comes in the train also, he'll come along with the Lay's packets and cool drink also. Okay. He will not only come with cool drink. He will not only comes with Lay's packet. He already knows that one. Okay. This is the most commonly repeating. So while selling also, he only sells in the train, right? Have we observed in the trains? Okay. With respect to the Lay's packets along with the cool drinks, they are going to sell, right? So that is the thing. Just you are considering the confidence and support. How these threshold values are selected means based upon your requirement. Just you are changing like this. For example, you have given first initially support as 0.9. You have seen, right? For 0.9, nothing is there. So minimum starts with 0.6 only. I'm getting some values. So here, if I give with that minimum threshold of 0.8, okay, or 0.9. Now with minimum threshold of 0.9 confidence, now how many products you are going to get? Only one. If you want to see multiple things, for example, I want to see with rice or with book, what is the other product is getting sold? Can I get like this with a 0.9? With 0.9, you can get that one. Here you are, can you get? Here you are getting only bread and jam. What about book? What about book? With book, which is the other one? I want to increase my book sales. Then what I have to do? So I have to reduce the threshold to 0.1. I'm reducing the confidence threshold to 0.1. And this support also I'm going to take to 0.1. Now here I will see with respect to, see total 67 transactions are there overall now. So what I'm going to do, I'm going to increase this minimum support and minimum confidence. And according to that, I'm going to see and which is having along with the book, the best combination along with the book. This threshold value is not a fixed value. Is that clear? Based upon your requirement, you are going to change the threshold values. Done? Any questions? So here the technical words called as antecedents and consequence means if this is purchased, what is the probability that this is going to be? Right? So for example, I'm writing here 0.1 or here I have written the 0.1. Okay, minimum threshold of 0.1 and confidence also minimum 0.1. Now what I'm going to do is here I'm going to take like this where I want the support value greater than 0.5. Separate again. First you take all of them, all the combinations, total 426 you have got. Okay, minimum support and minimum confidence you have got with the 426 transactions are there. 426 are there. Out of these one, if you want to have this one, first you create a data frame like this. All the possibilities, first you create the data frame and as per your requirement condition, you write your things. Now here you can identify with respect to where is book. Book is not having with the confidence, minimum support of 0.5 is also not meeting. Book is not meeting minimum support of 0.5 also, right? So you have to change to 0.3. Sir, in this book pen, 0.3 it is satisfying. Sir, but in between so many transactions are there. I want particularly in between 0.3 and 0.5. So you are going to take the filter, apply the end condition and go with the support. Take the support, whatever the support is there, less than 0.5. Between 0.3 to 0.5. I'm going to select between 0.3 to 0.5. So now I have got with respect to this is the values. Okay, so these are the values which support, right? So like this, we are going to identify. For example, I'm changing this one to 0.4. Okay, so many transactions are there with the support of 0.33. Multiple transactions are there with the support of 0.33. And if you want to display all of them means we are having the option called as pd.max options display. Display the maximum. So where we are going to write with respect to maximum columns is equal to 1000. So 1000 rows, max rows is equal to 1000. So you can use this one and you can display all the rows, right? So here the question is the minimum threshold, whatever the minimum threshold value of support, the minimum threshold of confidence, support and confidence, the minimum values, they are not fixed. They are not fixed. Both of them are not fixed. You have to change as per your requirements. If the DMART manager says for you to change this one, minimum support of this one means we have to work accordingly. If there's, for example, generally overall, we are going to analyze, okay, not as per the client requirement. We are only analyzing and we are only coming to a conclusion means we'll try with all the combinations and we'll say that, sir, these two are having with a good support and confidence. Means they don't know what is meant by support and confidence. We have to say that these two are having the good association. These particular combinations are having a good association, and you can improve your business by keeping like this. Okay. So the same thing was identified. Yesterday example I have told you, right? That is beer and diaper packets. Just they have observed the confidence and support and they have identified this combination suddenly. Now for this, what they have done is they have kept in order to, these both are having a good association. After the analysis, they identified they are having a good association. They have kept both of them side by side in their supermarket. Just they have increased their business. Okay, by keeping both of them side by side. Otherwise, beer will be in one end, diaper is in the other end. So the person who is interested in diaper, he is taking diaper and he is going out directly. So just they have changed the location to side to the beer bottles. They have kept the diapers. Now the person has visited the store and he has went to the diaper, which is side to the beer. He has picked the beer bottles also. That too, this beer bottles will be in the offer price because the beer bottles will have the more profit. So they have reduced and they have given some kind of offer on the beer. So like this, they have increased the offer by showing this one, and they have kept this diaper side to the beer bottles, and they have given the offer on the beer. By this, suddenly they have increased the more profits because I already have told you, right? They are having a good profits on the beer. Okay, beer bottle is, for example, 100 rupees means profit will be at least 50 to 55 rupees. Okay, 50% will be there. Almost 50% will be there in the beer. Okay, now it is having 50% of profit. So they have given with the offer price, they have brought this beer bottle instead of 100 to 80. Now the person has taken the diaper and he has selected that beer, and the beer sales has suddenly increased. They finally focused on the beer. They have not focused on the diapers. They want the beer packets. Beer should be more because this will generate more profits. At the end, they require this one. For getting this one, what is the best combination they have identified? Unexpectedly, they have identified that is the diaper. Okay, in the Google, type the diaper beer, diaper hyphen beer. Just type like this in the Google. You'll get the entire story. Okay, just type like this. You'll get one story. You read the story. Right? Their interest is with respect to beer. So they have increased the sales. Is that clear? Now, once again, let us take the random forest. Once again, I'm explaining the random forest. Now, what is meant by random forest? Random forest is where we are having forest. First forest means number of trees. Okay. Trees are nothing but decision trees. Here we are having with respect to called as decision trees. Right? So forest is nothing but number of decision trees. Now within this random, what is the meaning of random? Random means randomly selecting the subset of data. Randomly selecting the subset of data. Randomly selecting the subset of data. You are going to randomly select the subset of data. For example, this large amount of data was given. Okay. Assume there are total 1000 records are there. And you are having with respect to 5 columns. Into 5 columns are there. 1000 records into 5 columns we are having. Now total we are having this much of large amount of data. Now from this, it is going to randomly select subset. So it may select 10 records, it may select 15 records, it may select 10 records with 2 columns, it may select 10 records with 4 columns, it may select 100 records with 5 columns, it may select 1000 records with 5 columns, it may select 100 records with 2 columns. Like this, it may select different. Random selection. Okay, randomly you're going to select the data, completely randomly selecting. So it is going to take part of the data. So whatever the overall data we are having, overall data, within that overall data, part of the data, we are using the part of the data, and we are going to create the decision tree. So for this part, we have got the decision tree. So second part, one more part is there. For one more part, one more decision tree. For one more part, one more decision tree. Like this, we are going to select randomly. We are going to select. Sir, for example, total, assume there are 10 records are there, sir. Okay, first decision tree has selected 5. Second decision tree has selected 4 records. Third decision tree will be left out only 1, right? This is not like that. Where it is doing with respect to bootstrap. Bootstrap means with replacement. With replacement, we are going to work. Here, the most important point is with replacement. Means whatever the records has been used for the decision tree 1 can be used for the decision tree 2 also. The records can be repeated. Not as it is. Not as it is, the subset will be repeated. For example, you have taken here 5 records. Out of these 5 records, maybe one of the record will be repeated. Might be, may not be. Anything can be happen. Right? So where the repetition is allowed. Okay. So next 9 AM batch is there. So now repetition is allowed. Where we are having the repetition. So decision trees are going to be repeated with respect to repetition of the data. So here we are having the decision tree number 1, decision tree number 2, decision tree number 3, decision tree number 4, decision tree number 5, like this. It is going to create the decision trees. By default, it is going to create 100 decision trees. By default, it is going to create 100 decision trees by selecting random subset of data. So from that first decision tree, whatever the first decision tree was selected based on some data, not entire data, right? What is the difference between the normal decision tree? Normal decision tree versus random forest means push. Completely push. Close it. Long press. Okay, done. So now decision tree and random forest we are having. In the decision tree, what is the difference means? In the decision tree, full complete data is considered. Full or complete data. The complete data is considered and the tree was formed. Only a single tree is formed. Using the complete data, single tree is formed. One tree is formed. And using that tree, we are going to predict the data. We are going to do the predictions by using a single tree. By using a single one tree only, by using a single tree continuation completely, we are going to use the prediction and we are going to predict the future value by using a single tree. Now what happened here, it is this particular single tree was designed based on the trained data. As the trained data changes, decision tree also getting changed. And whatever the data you have given, for that data, it is fitting the entire tree. And it is having the overfitting problem. Every time the train accuracy, I'm getting the 100%. If I change the data also, train accuracy 100%. If I change the data also, train accuracy 100%. Whatever the data I give, decision tree always gives 100% as the train accuracy. That is the problem they have observed. Okay. Every time you give the whatever the train data, for example, your train data is 100 records. Out of 100 records, 70 records you are using for training purpose, 30 records you are using for testing purpose. Out of these 70 records, if you selected first 70 means 100% train accuracy. If you select from 20 to 90 records also, train accuracy 100%. If you select randomly other records also, train accuracy 100%. Whatever you give, 100%, always 100% it is returning. That problem they have observed in the decision tree. Now, how they can overcome this one means they have created the multiple decision trees. So by selecting the random subset of data, instead of collecting all the data, we'll go with random subset. Random set of data they have selected. Instead of complete data, they have taken random subset. Instead of forming one decision tree, they have formed the multiple decision trees. Now, for the data, whatever the data is there, according to the data, it is going to predict the some answer. Different answer it is going to predict. As the data changes, decision tree changes. As the decision tree changes, answer also changes. Data changes means decision tree changes. Decision tree changes means answer also changes. So now one more decision tree, answer has got changed. One more decision tree, answer has changed. Like this, they have taken different decision trees and different answers they have got. Now they have taken with respect to the mode. They applied the mode concept. Mode means which is most repeated one. That they have checked. If it is a classification problem, let us go with a mode. If it is a regressor problem, random forest regressor. If it is a regression problem, let us take the average value. From each of them, it is going to predict one answer. And from all the decision trees, whatever the answer it has predicted, I will take the average value of that one. If it is a regression problem, miss average value. If it is a classification problem, miss mode value they have selected for the random forest. Random forest means randomly subset. Now the trees, whatever the trees are there, these trees are independent to each other. They are not having any kind of dependency. Okay, this tree was formed with this data. So this tree has to form with remaining data only. There is no connection like that. Okay, they are not having any kind of connections. Is that clear? So they are having independent. They are independent to each other. All the decision trees are independent to each other. They are not having any kind of dependency between them. They are independent to each other. So since they are independent to each other, this is also called as parallel learning. This is not called as sequential learning. Whereas in the boosting, they are dependent. The second decision tree is dependent on the first decision tree. Whether it is a gradient boost, whether it is a raw boost, the second decision tree is depending on the first decision tree, the output of the first decision tree. But here, there is no kind of dependence. So that is the reason it is called as sequential learning. Whereas boosting is called as sequential learning, whereas random forest is called as parallel learning, where parallel learning was done with independent of each other. All the decision trees are independent to each other. And that too, none of the decision tree was pruned. No pruning. No pruning was done in the random forest. Each tree was grown completely. Already we have selected random subset, right? Again for random subset, again if you do the pruning, again it will lead to the underfitting. Already you have pruned here. You have selected only random subset. You are not completely selecting the data. You are going with the random subset. Now for this, again, if you do the pruning, if you apply the pruning, overall it is the data will be reduced. Overall the data is reduced, underfitting problem will come. So, sir, we have seen how to reduce the overfitting, sir. You have explained how to reduce the overfitting by lasso regression in the regression problems. You have explained by using the random forest, how to overcome the overfitting problem in the decision trees. And the pruning technique you have explained. And in the how to reduce the overfitting by using the hyperparameter tuning. You have explained whenever there is a overfitting problem, how to overcome. But if there is an underfitting problem, how to overcome, sir? Underfitting, whenever there is underfitting problem in the given data, how to overcome means we have to get more data. What is meant by underfitting means machine says that I'm not able to understand properly. If it says that I'm not able to understand properly means you have to give more examples. The only solution for underfitting the problem is more data you have to transfer. If you share the more data only, it will understand. Otherwise, it will not understand. For underfitting problems, the solution is you have to generate more data. That data is not sufficient.